All right, so let's continue on with the second part here. Now we're going to talk about the actual least squares line regression line. Least squares regression line. So if you go to page 183, it shows the line itself. So if I have points like this, I'm going to draw a regression line that looks like this. Okay, now notice the line that I drew does not go through any of the points. It doesn't have to go through any of the points. It can at times, it doesn't have to, right? So for each point that I have, I'm going to have a residual. So the residual here is going to be this. The residual here is going to be this, residual. So I'm just going to draw the residuals here, okay? And again, the ones on the top are going to have a positive residual because y actual is greater than the predicted value. The bottom ones are going to have a negative residual, okay? So this is what the residuals are going to look like. Now we're going to take these residuals, and I'm going to go ahead and square these. We're going to square these. In other words, we're going to take the square of them. So if you look at that geometrically, or from a geometric standpoint, if you look at it, it's the second one on page 183, the one to the right, where they actually took, if you were to take this residual, and I was to square it, it would become a square with an area that looks like this. Whereas this one is going to have a square that looks like this. In other words, the further away, the further away, the larger the residual is, the larger this square is going to be. And I'm going to add all the square areas together, okay? And the one that gives me the least area is called the least square regression line, okay? This is the line that you get when you go to your calculator, populate L1 and L2, and do the 1-bar stat, and you get a line. This is the line that you're getting. You're getting the least square regression line, okay? Also, you were taught that this was a line of best fit. It is one of the many line of best fits. It's the one that is most commonly used because you can get it easily from the calculator, okay? So if you look at that green box, it says, the least square regression line is a line that makes the sum of the squared residuals as small as possible. The reason why we square the residuals is because some of these are going to be positive values, some of these are going to be negative values, right? Depending on, because the residual can be positive or negative, right? But if they are further away, we want to make sure they all count equally. So that's why we square it. Okay, we square it. Okay. So that's that. If you go to page 184, it tells you how to do the linear regression. You know how to do that. You've done this many, many times. I'm not going to go over that. Okay, so then we go to page 185 and we have what is called the residual plot. The residual plot is that you have these residuals, okay? Now I'm going to go ahead and plot that. There's a function in your calculator that does the actual plot, okay? The green box shows that the residual plot. The residual plot is a scatter plot that displays the residuals on the vertical axis and the explanatory variable on the horizontal axis. So it's going to take this, what we have here, if I put this into a residual, it's going to look something like, I'm going to go ahead and do a condensed version here. So the residual here is going to be positive, right? Positive. Down here is going to be negative. Up here is going to be slightly positive, negative, positive, about the same right there, negative, about the same right there. A little smaller one. You have a larger one up here, a smaller one, looks like about here, here, larger one, smaller one. This is what the residual plot. So I just plotted, I took each of these residuals, okay, and I moved it over here. That's all I did. Small one, medium one, larger one up here. So I moved it. So basically I'm tilting this, and I'm taking this line, and I'm tilting it like this across and straight, and I'm plotting just the residuals here, okay? So if you flip to page 186, just how to interpret a residual plot. To determine whether the regression model is appropriate, look at the residual plot. So we're gonna look at this plot right here. If there is no leftover curved pattern in the residual plot, then the regression model is appropriate, okay? So in other words, if you are actually using a linear regression towards something that is actually linear, then you'll get a random dots of residual plots, okay? If you were to try to use a least square regression line to a data that looks, if you had data that looks like this, which is clearly not a linear model, and you try to use this, a linear model, to do this, when you plot the residual lines, if you look at the residual lines, what are you gonna have? You're gonna have a positive, then you go negative, 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 positive, positive, right? So it's gonna be negative, then we're gonna go positive, then negative, 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 small negative, positive, positive. You can see that the residuals will give you a curved pattern. Clearly, you should not be using a linear regression line here, right? In other words, if the residual plot gives you something that has a distinct pattern here, you should not be using that line, okay? So that's what it says here, right? It says in the first bullet, it says, if there's no leftover curved pattern in the residual plot, then the regression model is appropriate, okay? If you look at something that looks like this, then it's not. You shouldn't be using it, okay? Look at the example, pricing diamonds. Is a linear model appropriate to describe the relationship between the weight in carats and the price? Okay. If you look at the residual plot, what does you say? What does it look like? Is there a distinct pattern there? They are definitely not random, correct? Right? If you look at that bottom of page 186, if you look at the residual plot, there is a pattern, which means that the linear model is not appropriate, okay? All right? And then go to page 187, it tells you how to do a residual plot. Okay, I'll leave that up to you guys to learn how to do this, okay? And yes, this will be, this is definitely gonna be, this is testable, okay? Doing the residual plots, all right? And, we're done for the day. We're done, that's where we need to stop. Okay, all right. Any questions there? That